In this video, we're going to look at two different graphs. The first is going to be the absolute value of y is equal to f of x. Okay, and as an example function f of x, we're going to use 9 minus x squared. So that's an upside down parabola, which I'm sure you can sketch. So that's meant to be symmetrical about the y-axis. It cuts at -3 and at 3 using the difference of two squares, and the y-intercept is 9, and that graph is y equals f of x. Okay, and what we want to do is we want to sketch, and I'll do it on the same axes, we want to sketch the absolute value of y equals f of x. Okay, so what do we do? Well, the first observation I make looking at this is that this is always greater than or equal to 0, which means the x values which I put into my function have to be only the x values that make f of x greater than or equal to 0. So f of x has to be greater than or equal to 0, which gives us the domain of our new graph, and the domain is going to be the x values that make this graph positive. So we're going to have x is between -3 and 3. And the second thing that I'm going to observe is that the absolute value of y, just by definition, is equal to y if y is greater than or equal to 0, and it's equal to -y if y is less than or equal to 0. Okay, so that's just the definition of absolute value, and now I'm going to use this to basically write down what y is in these two different cases. So we're going to get another function defined in two parts, or another object defined in two parts, and y is going to equal to two different things if we're in those two different cases above, y positive and y negative. Okay, so what I'm going to do is I'm going to say if y is greater than or equal to 0, then if we're in this case, the absolute value of y is equal to y. So looking at the formula, I can replace the absolute value of y just with y, and I get y is equal to f of x. So y is equal to f of x if y is greater than equal to 0. So that means if we're in the upper half plane, I just sketch what I've already got of f of x. So if I'm in the upper half plane, I just sketch what I've already got of f of x. So that's the first half of our graph. The second half of our graph, we're going to do the same thing. We're going to say if we're in the negative case, so if we're in this case, then the absolute value of y is equal to -y. So if I look at my function, I can replace the absolute value of y with -y, which means if I put the negative sign on the other side of this equation, I get y is equal to minus f of x. So y is equal to minus f of x. So if I want to sketch now the second half of this graph in the lower half plane for negative y, I need to draw the negative of what I've already got. I need to draw the negative of f of x. So basically I draw the negative of f of x. And there you have it. That's the graph of the absolute value of y equals f of x. Just to give you an example of something similar that you should already know before learning about this graph is, remember the graph of y equals f of absolute x. We get this graph by replacing x by absolute x, and what this graph does is you take everything in the x-axis that is positive, so you take everything over here, and then you reflect that over here, so you basically end up with the same thing. It's an even function. Okay, so what we've done in this case was we took everything where y was positive, because in this graph we're replacing y by absolute value of y, right? And you can see here. So we take everything where y is positive, just like we took everything where x was positive, and then we reflected it about this axis instead of reflecting it about this axis, and we ended up with something that's symmetrical about the x-axis. Okay, so that's the graph of absolute value of y equals f of x. Now the second graph that I want to look at is very similar. Okay, it's basically the absolute value of y doesn't just equal f of x, but it equals the absolute value of f of x. So I'll put that on a new page. So the second case, the absolute value of y equals the absolute value of f of x. Okay, and we'll use the same example. Basically, I mean, I'll write it slightly differently. I'll say f of x separately over here, the same thing, minus 9x squared. So we've got the same graph as before. Again, this should be symmetrical about there, 9 minus 3, 3. And of course, this graph here is y equals that thing, right? That's this graph. And what we want to do is we want to draw over here the absolute value of y equals the absolute value of f of x. So that's what we want to draw out of this. If I come over here and start making observations, well, I don't need to worry about the domain anymore because this side's positive and this side's positive. So even if I put in an x value where f of x is negative, well, the absolute value of a negative is positive, so this all becomes positive again. So that's okay, so I don't need to worry about the domain. Looks like the domain is just going to be the domain of f of x. But I am going to do the same thing I did before when I unpacked absolute value of y. So I'll write it down again just so that we can refer to it. The absolute value of y equals y or minus y in the two cases when y is greater than or equal to 0 or y is less than or equal to 0. So you should be, you should get very familiar and comfortable with doing this. You should be able to do this in your head really. And then what I'm going to do now is try and see what y is actually equal to, so I can graph this in the two different cases. If y is greater than or equal to 0, or if y is less than or equal to 0, right? So in the first case, if y is greater than or equal to 0, I'm here and I can replace the absolute value of y by y. So I put a y in here and I've got y is equal to absolute f of x. So y is equal to absolute f of x. So basically, on the top half, I get the absolute value of f of x, which the absolute value of f of x takes everything that's positive, but then also takes the reflections of any negative bits, okay? So what I've graphed here is y equals absolute f of x. And now let's find out the bottom bit. Well, we're in the second case where for negative y. So for negative y, absolute y is equal to minus y. So where I say absolute y, I put minus y, but I put the minus sign on the other side, so I get y is equal to minus absolute f of x. Y is equal to minus absolute f of x when we're in this second case. Okay, so what's the negative of absolute f of x? Well, I basically reflect what I've got down below the axis. So I get the rest of the graph filled in. Okay, so there you have it. It's quite a full graph, if you like. It's got all the positive and all the negative bits reflected in the x-axis. Okay, so one way to think about it is the absolute value of f of x on the top and minus the absolute value of f of x on the bottom. And a second way to think about it is basically you sketch the function and then you sketch the reflection of the function.